We will now determine the rate of change of area of the right triangle when one leg is increasing at a rate of 5 kilometers per hour and another leg is decreasing at a rate of 14 kilometers per hour. Since the other leg is decreasing, I have to indicate this with negative sign. And we are also given that at a certain time t naught, the x of t naught, that is the distance, the increasing length is 3 kilometer and the decreasing leg is about 9 kilometer. So in this situation, we have to determine the rate of change of area of the triangle. Let's see how to determine that. So first, I'm going to write down an expression for the area of the triangle in terms of t. This is area of the triangle. We know that the basic formula to find the area of a triangle, half BH, where B represents the base of the triangle and H is the perpendicular or the height of the triangle. So since this is a right triangle, we can consider any one of the leg as base, or otherwise we can consider them as height also. So I'm going to consider this x of t, that is the horizontal leg, as the base and the vertical leg as the height. So therefore this equals 1 by 2 times of x of t times of y of t. So we have written the expression for the area function. Now we have to find the derivative so that we determine the rate of change of area of the triangle. So we have to take the derivative on both sides. The derivative of a of t with respect to time, we can symbolically write down as a prime of t, and this equals half. We have to find the derivative of this expression inside the bracket. Since this is a product involving functions in x and y, we have to use the product rule. So according to the product rule, we take the derivative of the first function, that is x prime of t, and multiply with the second function as it is, so it becomes y of t. Let me put the square bracket over here. Plus we then take the derivative of the second function, multiply with the first function, so I write down as the first function x of t and the derivative of the second function, which is y prime of t. And since we have to determine the rate of change of area at the time t naught, that is at time t naught, we can represent, or we can replace all the t's in terms of t naught. So therefore this becomes a prime of t naught, and this equals half of x prime of t naught times of y of t. We put the square bracket, plus this is x of t naught times of y prime of t naught. Now we just have to substitute or replace the values which we already know. We know that x of t naught equal to 3. I'm going to replace this as 3, which is x of t naught. So this can be replaced as 3, and y of t naught is 9 kilometers. I'm going to put only the unit, only the number without the unit. So this is 9. And we also know the derivatives, that is x prime of t is 5. So this derivative is irrespective of the time. Even at time t naught, we can utilize the same value. So therefore this becomes x prime of t naught. I can replace this as 5, and this y prime of t naught, I can replace it as negative 14. So I put on top of each of the terms. Now let's simplify this. So this is going to be half of 5 times of 9 is 45, and 3 times of negative 14 is negative 42. So this is equal to 45 minus 2 is 3. So 1 by 2 times of 3, and this equals 3 by 2. We divide 3 by 2, we get the value as 1.5. So since this represents the derivative of the area function, that is the rate of change of area, we put the unit as kilometer square per hour. So we have answered this question, that is we determine the rate of change of area of the triangle with respect to time, which is 1.5 kilometers per hour at time t naught. We now match the expression with the correct units. So first let's understand the unit for x prime of t. Basically, x prime of t is the rate of change of the distance along the horizontal direction. So basically, this is distance over time. And in this problem, the distance is measured in kilometer and time is measured in hours. So basically, this quantity is equal to, or the unit of this is kilometer per hour. So we choose this one, or we shade this circle. Now let's answer the unit for A of T naught. We know that the area of a quantity is basically the length times width. It's basically a two-dimensional quantity, or it is in this case for a triangle, it is a half of base times h, or one leg times another leg. So it's basically a product of two similar quantities. So this means this will be half of kilometer times kilometer. Since this 1 by 2 is a constant, we can just ignore this. And if you look at only the unit, it is kilometer times kilometer, which is equivalent to kilometer square. So therefore, the unit of A of T naught, that is area of the triangle at certain time, T naught is the unit of this is kilometer square. So we can shade this circle. And finally, we find the area unit of y prime of t naught. So it is more similar to this x prime of t. So y prime of t, this is also the rate of change of distance along the vertical direction. So this is also once again distance over time. So this is once again kilometer per hour. Kilometer per hour. And so we choose, since it is for t naught or for any values of t irrespective of the values of t, the unit is going to remain the same. That is since it basically represents the rate of change of distance, that is distance over time, the unit of this y prime of t, y prime of t naught, and this also kilometer per hour. So we shade this circle.